Let's talk about rational expressions. When you see the term rational expression, think ratio. It'll help you memorize what they actually are. So let's talk about what they are. A rational expression is the ratio of two polynomials. They can usually be simplified by factoring, but not always. As you can see on the left here, 5 over 5 minus 2x can't be simplified any further than it already is. But a lot of them can. We're going to learn more about factoring later, but for now just follow along to get the concept down. We have a rational expression here, x squared minus 2x minus 8 over x squared minus 9x plus 20. The numerator can be factored out to x plus 2 times x minus 4. If you multiply these together using the distributive property, you get what we have in the numerator above. Likewise for the denominator, that can be factored out to x minus 4 times x minus 5. And you can probably already see that we have like terms in the numerator and the denominator now. But we've rewritten it below using the associative property. And so the x minus 4 in the numerator is directly over the x minus 4 in the denominator. So you can cancel these out, and what we're left with is x plus 2 over x minus 5. If this seems kind of strange to you, think about it in terms of simplifying fractions that consist of integers. For example, 5 over 10 is the same thing as 1 over 2. There are different numbers involved there, but they both produce the same result. Likewise for rational expressions, try plugging in some x values for the expression at the top before we factored and canceled out, and then try substituting those same values into the result we got. You'll soon see that you get the same answers. Let's take a look at one more of these real quick. We have x squared minus 25 over 5x minus x squared. The numerator can be factored out to x plus 5 times x minus 5. And the denominator can be factored out to negative x times x minus 5. Again, after simplifying we have like terms here, so we can cancel out the x minus 5's. And what we're left with is minus x plus 5 over x. The problems here have been mostly centered around quadratic expressions, but you can factor and simplify lots of rational expressions. This one's a little more complicated to see the pattern in, but with some practice you can get used to it. Later we're going to go over some methods for simplifying these that are more straightforward. But let's take a look at this problem for now. In the numerator we have x squared minus 1. In the denominator we have x cubed minus x plus x squared minus 1. The numerator can be factored to x plus 1 times x minus 1. And the denominator can be factored to x plus 1 times x squared minus 1. The denominator can be further simplified to x plus 1 times x plus 1 times x minus 1. So what we have is for the numerator we have x plus 1 times x minus 1. Well, we have both those terms in the denominator as well. So when we cancel those out, we're left with a 1 for the numerator and x plus 1 for the denominator. Let's take a break here. When we come back, we'll be discussing some of what we've seen here, which are quadratic equations, where the highest exponential value is x squared, hence the name quadratic.